All right. So welcome to the continuing section of chapter 1.2, where we are looking at linear equations and rational equations. You would notice that in the previous example that we looked at, in the denominator, we only had constants or numbers. But whenever we have a variable in the denominator, such as in this example, that we call this kind of equation a rational equation. And the consideration or some other factors that we have to take note when we have rational equations is that, for example, in this particular example, if x is equal to 0, we notice that the denominator for 5 divided by 2x would be 5 divided by 2x, which is 2 times 0, which is 5 divided by 0, which is an undefined expression. We do not divide by 0, so it's undefined. The same thing could result in the case of 1 divided by 3x if x is equal to 0. So what we can say here is that x is equal to 0. It's not part of this. It's not part of the solution to this equation. X is equal to 0. It's not part of the solution. Or this x is equal to 0. It's not part of the solution. Or x cannot be equal to 0. X cannot be equal to 0. Otherwise, we have an undefined expression. And so when we solve this, the solution set for this problem, it cannot include x is equal to 0. So x is equal to 0 will not be included in the solution. All right, so similar to how we solved the previous example, when you have a rational equation such as this form, the first thing that we do is to look for the LCM. So the LCM is an expression where in which each denominator can divide. So we have 2x, 18x, and 3x. So the LCM, or the common expression where each of the three denominators can divide, would be 18x. 18x is what is common to 2x, 18, and 3x. All three denominators can divide 18x. So the next thing that we do is to multiply through every term by 18x. So 18x times 5 divided by 2x. And this is equal to 18x times 17 divided by 18. And this minus 18x times 1 divided by 3x. All right, so 2x divides 18x, divides 18x, forgot about the x, divides 18x 9 times. 18 divides 18x, x times, and 3x divides 18x 6 times. So we have 9 times 5 is equal to 17x minus 6. All right, so now you can group the numbers on one side. 9 times 5 is 45. And we add 6 on both sides, so plus 6 is equal to 17x. All right, and 45 plus 6 is 51. So 51 is equal to 17x. And now we can divide both sides by 17. So that gives us x is equal to 3. 51 divided by 17 is 3. So that gives us x is equal to 3. All right, so let's check whether x is equal to 3 is the correct solution by substituting x is equal to 3 to see if we get the same numbers on both sides. So on the left-hand side, we have 5 divided by 2x. So if we substitute x is equal to 3, this becomes 5 divided by 2 times 3. And this gives us 5 divided by 6. All right, so let's check for the right-hand side. To the right-hand side, we have 17 divided by 8, 18. No, 17 divided by 18 minus 1 divided by 3x. All right. So if we substitute x is equal to 3 into this, we get 17 divided by 18 minus 1 divided by 3 times 3. So this is 17 divided by 18 minus 1 divided by 3 times 3, which is 9. All right, so the LCM for this is 18. 18 divides 18 once. 1 times 17 is 17. Minus 18 divides 9 is 2. And 2 times 1 is 2. So this gives us 15 divided by 18, right? And 15 divided by 3 is 5. 18 divided by 3 is 6. So we see that the right-hand side is equal to 5. The right-hand side is equal to 5 divided by 6. And the left-hand side is also equal to 5 divided by 6. So that means x is equal to 3 is a solution. X equal to 3 is a solution to this rational expression, this rational equation. X is equal to a solution. X is equal to 3 is a solution to this rational equation. All right. All right, so let me share my slide again. Let me stop sharing and share my slide again. All right, so let's look at another example. It says, let me share my slide again. Let me share my blackboard again. Let me write down the problem. Find all values of x for which y1 is equal to y2. And so let's write down what y1 is and what y2 is. So y1 is equal to 1 divided by x plus 4. So y1 is equal to 1 divided by x plus 4. And 1 plus x minus 4 plus 1 divided by x minus 4. And y2 is equal to y2 is equal to 22 divided by x squared minus 16. X squared minus 16. All right, so we have to find the values of x for which y1 is equal to y2. So the first thing is we set y1 equal to y2, and that would be 1 divided by x plus 4 plus 1 divided by x minus 4 is equal to 22 divided by x squared minus 16. All right, so before we find the LCM, it would be a good idea to simplify what x squared minus 16 is. So x squared minus 16, we call the difference of two squares. We call it the difference of two squares. And it's basically x minus 4 times x plus 4. If we expand this, we're going to have x squared minus 16. So let's try it. X times x is x squared. X times 4 is 4x. Negative 4 times x is negative 4x. Negative 4 times positive 4 is negative 16. All right, so positive 4x minus 4x, that goes to 0. So we get x squared minus 16. So x squared minus 16 is the same as x plus 4 and multiplied by x minus 4. So we can rewrite this rational equation as 1 divided by x minus x, x plus 4 plus 1 divided by x minus 4 is equal to 22 divided by x minus 4 multiplied by x plus 4. All right, so at this point, we can find the LCM. And so the LCM, what is common to all these three is the expression x minus 4 times x plus 4. This is the LCM because every single one of these can divide x minus 4, x plus 4. So we multiply through by x minus 4 and x plus 4. So x minus 4 times x plus 4 times 1 over x plus 4 plus x minus 4 times x plus 4 times 1 divided by x minus 4. And this equals to 22 divided by x minus 4 times x plus 4 times x minus 4 times x plus 4. All right, so we can simplify this. So x plus 4 here divides x plus 4. So we have x minus 4 here times 1. And plus x minus 4 here divides x minus 4. So we have x plus 4 times 1. And this is equal to x minus 4, x plus 4 divides x minus 4, x plus 4. So this is equal to 22. So we take away the brackets by expanding, multiplied by 1, which just gives us the same thing. So we have x minus 4 plus x plus 4 is equal to 22. So x plus x is 2x. So we have 2x, and negative 4 plus positive 4 is 0. So 2x is equal to 22. And so at this point, we can divide both sides by 2. And if we do that, 2 divides 2 once, 2 divides 22 11 times. So we get x is equal to 11. Yeah, so at the beginning, before even we begin to solve this problem, right? Because it's a rational expression, we have to test the denominators for values of x for which this rational expression is not defined, or values of x which cannot be included in the solution. So you will see that in the denominator we have x plus 4, and we have x minus 4, right? So when x is equal to negative 4, if x is equal to negative 4, then x plus 4 becomes negative 4 plus 4, which gives us 0 at the denominator. And on the other hand, if x is equal to positive 4, then x minus 4 becomes 4 minus 4, which gives us 0 at the denominator. So that means x is equal to negative 4 and 4 are not part of the solution. X cannot be equal to negative 4 or 4. X cannot be equal to this. So these are excluded from the solution. X cannot be equal to negative 4 or 4. Because if that happens, then we get a 0 at the denominator, which makes our rational equation to be undefined. So x is equal to negative 4 or 4 is undefined. Again, we can check whether our solution x is equal to 11 is right, is the right solution. And we can do that by substituting x is equal to 11 on both sides of our equation. So on the left-hand side, we have 1 divided by x plus 4 plus 1 divided by x minus 4. So on the left-hand side, we have 1 divided by x plus 4 plus 1 divided by x minus 4. So if we substitute x is equal to 11, this gives us 1 divided by 11 plus 4, which is 15, plus 1 divided by 11 minus 4, which is 7. 11 minus 4, which is 7. And so the LCM for this is, you can find the LCM for this, which will give us, which will be the least multiple for which both 15 and 7 can divide. And so let's see, what would that number be? So if we multiply 15 by 7, we get 105. So 105 is a number that both can divide. So 105. 15 divided by 105 is 11. And 7 divided by 105 is 7. Is 7 times 15 is 15. Also 15. Oh, okay. So I made a mistake here. So the LCM is 105. So 15 divides 105 7 times. and 7 divides 105. 7 divides 105 15 times. So this gives us 22 divided by 105. All right, so let's test for the right-hand side. So the right-hand side, we have 22 divided by x squared minus 16. So we have 22 divided by x squared minus 16, right? So this is equal to 22 divided by x squared. So 11 squared is 121, and this minus 16. So this gives us 22 divided by 105. So we got 22 divided by 105 on both sides. So that confirms that x is equal to 11 is a solution to our rational equation. All right, so let's switch back to our slide. Let me switch back to my slide. Let me switch back to my slide. And let's continue. So whenever you have a rational equation before you solve, the first thing is to check for the denominators, the points where we have a restricted value in the denominator, or we have a certain restriction on whatever number the variable can take on in the denominator. So that's the first thing we have to check to make sure that is excluded from our solution. So there are three kinds of equations. We have an identity, we have a conditional equation, and we have an inconsistent equation. The rational expressions that we saw, they were all conditional equations. Their condition is that x, the condition we place on them is that x cannot be equal to we cannot have x to be a number such that the denominator evaluates to 0. So those are conditions that we place on the solution. So those examples of rational equations that we have just looked at are all called conditional equations. An identity is an equation such that if you solve it, you get it is true for all real numbers. There is no condition on the value of x. It is true for all real numbers. An inconsistent equation is one which has no solution. When you solve it, you solve it and the x gets missing out of the solution. For example, let's look at for example, if we have 4x minus 7 is equal to 4x minus 1 plus 3. Let us try to solve this. Let me share my blackboard. For example, let us solve this equation and see what we get. So 4x minus 7 is equal to, let's expand the parentheses. 4 times x is 4x. 4 times negative 1 is negative 4 plus 3. All right, so if we group the x's on one side, we have 4x minus 4x is equal to negative 4 plus 3 and plus 7. So 4x minus 4x gives us a 0, and this is equal to minus 4 plus 3 is positive 1. and it's positive 1 and plus 7, which is equal to 8, right? So this is false, right? This is false. 0 cannot be equal to 8. So this is false. And so this tells us that this equation this equation does not have a solution. It has no solution. This equation has no solution because the solution we're getting is false. 0 is not equal to 8. And so that tells us that this equation this equation does not have a solution or is inconsistent. It does not have a solution or is inconsistent. So that's what we say. A solution or inconsistent is an example of inconsistent equation. All right. All right, so let's look at also another example where we can categorize the equation as an identity. So, for example, 7x plus 9. Let me move on to the next one. 7x. Another example here: 7x plus 9 is equal to 9 times x plus 1 minus 2x. 9 times x plus 1. 9 times x plus 1 minus 2x. So let's try to solve this and determine whether the solution to this equation is an identity, is inconsistent. We already know this is not a conditional equation, right? There are no restrictions on the value of x. It's not a rational equation. All right, so 7x plus 9 is equal to 9 times x, which is 9x, plus 9 times 1, which is 9, minus 2x. All right, so let's group the numbers on one side. So we have 7x plus 9 is equal to 9x minus 2 is also 7x plus 9. Right, so this equation is an identity because what we have on the left is what we have on the right. So this is an example of an identity, an equation that is an identity, right? We have 7, if we subtract 9 on both sides, we have 7x is equal to 7x, and we divide both sides by 7. We have x is equal to x, which is a true statement, which is true. And so the fact that we are getting the same thing on here, on the left, and the same thing on the right, it means this is an example of an identity. All right, so let me share my slide again. All right, so let's look at this applied example. It says, persons with a low sense of humor have higher levels of depression, higher levels of depression in response to negative life events than those with a high sense of humor. And this can be modeled by the formula D is equal to 10 divided by 9x plus 53 divided by 9. So let me write down this equation on our board. All right, so it goes ahead to say, if X represents the intensity of a negative life event and D is the average level of depression in response to that, if the low hemo group averages a level of depression of 10 in response to a negative life event, what is the intensity of that event? So we have this application problem here. We have two variables, D and X, right? And one of them is given, and so we have to find the other. And we are told that X represents the intensity of negative life events, and D is the average level of depression in response to that event. And we are given that if the low hemo group averages a level of depression of 10, so that means D, the level of depression is 10, right? So D is 10, and so we are to find the response to a negative life event. We are to find the intensity of that event. And we are told X represents the intensity of that event. So we are given D is equal to 10. So we substitute D is equal to 10 and we try to solve for X. All right, so let's go to our blackboard. So we are given that, we are told that D is equal to 10. So we have this rational, we have this equation here. 10 is equal to 10x divided by 9 plus 53 divided by 9. All right, so as usual, we have to multiply through by the LCM. So we can see that the LCM here is 9. 10 is the same as 10 divided by 1. So a number that can divide 1, 9, and 9 is 9. So if you multiply through by 9, we have 9 times 10 is equal to 9 times 10x divided by 9 plus 9 times 53 divided by 9. So we have 90 is equal to 9 divides 9. 90 is equal to 10x plus 9 divides 9 is equal to 53. So if we subtract 53 on both sides, we have 90 minus 53 is equal to 10x. All right, so 90 minus 53 gives us 30, gives us 37. So 37, let me see whether I made a mistake in here. So 37 is equal to 10x. So if we divide both sides by 10, you see that x is equal to 37 divided by 10. All right, so this is where we like to end today's section 1.2, and so I'll see you in the next video as we discuss 1.3. And 37 divided by 10 is the same as 3.7. So this is also the same as 3.7. All right, so we'll end here, and we will continue. We will continue in the next as we discuss section 1.3.